Yeah, show the camera.
That's good. Yeah, so Ryley will work together with me on this presentation and give you some introductions of his work as applied breeding geneticist, and also some history and the development of hybrid turkeys. So first of all, we would like to give an introduction of Hendrix Genetics, who we work for. So Hendrix Genetics today. So Hendrix Genetics is a global breeding company, and today we have 2,800 employees worldwide, and we have 25 countries with owned facilities, and we have 580 million turnover in euro, and 44, maybe more than 44 geneticists nowadays, and 29 nuclear breeding centers. And we have multiple species. There are 4 terrestrial species, including laying hen, broilers, but more colored broilers, traditional poultry, and turkeys, and then swan. And we also have 4 aquaculture species, salmon, shrimp, trout, coho salmon. And then we have 326 farms at multiplication and GP levels. Here is a map showing an example of our global operations in many countries, and in total 25 countries. So it's spread everywhere worldwide. And highlighted in green here, Boxmeer is our headquarters in the Netherlands. And then we have tailored species for different countries, which meet the customer preference and also the market preference. Work sometimes. And here is a diagram showing the organization of 5 species-specific and 1 region-specific business unit of Hendrix Genetics today. So first of all, we have our Research Technology Center and also the Cooperate Service in Boxmeer office, the headquarter office. So the Research Technology Center there, we have multiple groups. For example, the global genotype team, which do the genotype service for all business units, and we have the genomic selection and evaluation group, and we have the digital phenotyping group. So all those groups work together on innovations and advanced research. So they do research at a higher level, and together with the Cooperate Service, they try to figure out how we implement those innovations and advanced research to each business units. So they work on the multi-species level and more advanced level. And going downwards at this diagram, we have specific business units here. So the first layers, and then turkeys, aquaculture, and swan, and traditional poultry. And each business unit, they run independently, but also interactively to share experience. And especially at the R&D level, we have multiple projects running in parallel, and we share experience and share ideas all the time. And then there is another 1 region-specific business unit established more recently, which is BU China. It contains multiple species. So at the moment, we don't have a specific R&D group in there for China. So more or less the sales and the management group, and trying to develop more business in China. So for now, the species in China include swan, shrimp, layers, and also traditional poultry. So here are the the genetic brands we have for each business unit. So we have 6 strong genetic brands for layers, and 1 for hybrid, 1 for turkeys, which is hybrid S, and then 3 genetic brands for aquaculture and hypor for swan, and then Cecil is the traditional poultry. And under each genetic branch, we have tailored commercial products that meet different market, different countries, according to the customer's preference. And then next, I'm going to pass the floor to my colleague, Dr. Ryley Vanderhout, to give us an introduction about hybrid turkeys.
Celebrity guest speaker. Thanks, Emily. So a little bit on hybrid turkeys. Hybrid turkeys was founded in 1953 by Milo and Ross Shantz, so two brothers in Canada. It was the largest primary turkey breeder in the world, and now is one of two companies that provide turkey genetics worldwide. Dedicated team of experts. I think that's kind of applicable to most companies. And yeah, strong product portfolio and different products for different markets. In terms of our global supply chain, this is our structure. So Canada holds a headquarters, turkey headquarters, has some other species in there as well, hypor and some saso or traditional poultry layers people in there, but priority is turkeys in this headquarters that's in Kitchener. And we have all of our pedigree facilities as well as a handful of GP and GGP contract farms. We have one hatchery and a laboratory where we do testing and send out blood samples for genotyping and et cetera. From the US standpoint, that's kind of more downstream in the production. That's where you'll find all of your big farms with breeders and commercial stock. Obviously, there are some of those in Canada as well, but primarily in the US. US turkey production is by far the most in the world. I think if you add up the second most to the 10th most production, it's about the same as US alone. So US is very heavy in the turkey market. From a EMEA or European standpoint, we have some turkeys in the Netherlands. Obviously, our Hendricks Genetics headquarters for all species is there. But you can think of France as being the Canada of Europe and Poland as being the US of Europe. So France is where we have all of our pedigrees. We have some GGP and GP, as well as some parent stock farms, as well as a hatchery and a lab. And then Poland is kind of more of your breeder stock and commercial stock in Europe. In terms of facilities, a little bit more in depth here. Ontario is where all of our pedigree facilities, hatchery, breeder sites, and lab are located. Nothing else kind of around Canada in terms of internal Hendricks facilities. And then everything else is in this kind of Midwest area where most of the agriculture and everything is grown in the US. Flat land, you see your dog run away for miles. Yeah, good land for breeding. Here's some pictures of our facilities in Canada. So we have 3 pedigree farms, as mentioned. Our biggest is Maple Glen. This is located in Ayr, just kind of west of New Hamburg off the 401. Woodside is 2 streets west of the the Allure facility, which is, yeah, arguably not a great spot, but we deal. And then Birkdale is our newest and smallest of the 3. And that is up in Markdale, which is like an hour and a half kind of northeast of here. This is what our hatchery looks like. Not a massive hatchery, but it deals with all of our pedigree birds and then the odd flock here and there for kind of lower level GP, GGP. And this is kind of like the back corner of our lab facility. It's kind of hard to see because there's a bunch of trees everywhere, but very conspicuous little building. Yeah, so those are our facilities. And this is our structure. So typical pyramid structure here from a breeding company standpoint. Pure lines is our pedigree birds that I deal with on a day-to-day basis. And then you have grandparent or great-grandparent, grandparent, parent stock, and commercials. So from a turkey industry standpoint, these top three are all us. We sell then to breeder companies who breed the crosses, hatch those birds, who then sell to commercial companies that grow out the commercial product for slaughter and sale. There's a cool little multiplication step here that we like to show. So one pedigree tom that I deal with up in the top can be upwards of 3.8, almost 4 million pounds of turkey meat from a commercial standpoint, just based on that multiplication factor. And I have here a couple arrows. So obviously our R&D activities, as I mentioned, we deal with the pure lines the most and have a little bit downstream. But what we're trying to do in the future is get a little bit more of that downstream data and bring it back up. So one of these projects that we have here, a little acronym, CCPS, which is Combined Crossbred Purebred Selection. So what we've done with this project, I'll touch on it briefly, is take our male line tom, mate it with a female line hen, place those birds in a commercial environment, and collect data on them that we can then relate back to those sires and have, say, a crossbred livability trait to be used in our index. So it's a cool little project there. As you can see here, though, there is 3 lines that make up our commercial product, very similar to pork industry. We have a male line and 2 female lines. Cross them together, you get the best of all 3. And that is our final product, which we call the converter. Speaking of our core products, we have 3. So we have 2 heavy market products and 1 medium market. The heavy products, we have 1 for North America and 1 for Europe. The hybrid converter, most widely used turkey in the world from our standpoint, and the converter Novo, which is a slightly smaller, more efficient bird that's focused for the European market. As well as in the European market, we have that more medium-sized bird. They like the smaller birds more than the Americans, so that's why we got to make a medium size, and that we call the Grade Maker Evo. So some innovative selection methods. I'll touch on a couple slides and then pass it back to Xuechun for some cool videos. This is our structure. So it's a big circle that repeats on a daily basis. We go from eggs, which came first, turkey or the egg? I don't know. Eggs go to our hatchery, which I've shown. All the birds are hatched and banded with a unique identification. Those birds are then sent to a rearing barn, one of those 3 pedigree farms that I showed, where they will grow out for about 30 weeks. In those 30 weeks, we collect phenotypes, we collect genotypes. All that data comes to mine and Xuechun's desk, where we then can go and select the best tom and hen based on specific indexes for each line. From those best toms and hens, they are then transferred to a lay barn, which again repeats the cycle. Those eggs are laid, sent to the hatchery, and so on. And there's your little innovations and automations. So these are 2 key terms for us. So we want to always innovate, and a lot of our time now is spent on automating trait collection and getting accurate, more data so that we can better select these birds. Labor is very difficult to find nowadays, especially when you're talking on farm. We like to say you can get paid 25 bucks an hour to sit in a hot turkey barn where you're getting attacked by turkeys, or you can go make coffees at Starbucks. A lot of people will probably choose the latter, so that does make it difficult. So we got to automate as much as we can. Oh, no, it did it. This is our typical selection program for from tom side. Hen side's a lot less involved, so that's why we just show the toms here. So 100% placed, you get a little bit of mortality in the first couple weeks. And then our first kind of handling, as we like to call it, is at 12, 13 weeks of age. From this, we place birds on feed conversion testing. Those birds are then stopped feed conversion at around 19, 20 weeks of age. In the middle there, pick out any birds that are sick, can't walk, etc., phenotypic culling. At this 19-20 week of age, we do another phenotypic culling, mostly based on the ability to walk. That is a key trait for us, because if a bird can't walk, won't last the full production cycle, farmers get mad, they have to cull birds, and they lose out on a lot of money. These culls, we don't just throw them away, we get a little bit more data out of them. Breast meat yields, we send them to the slaughterhouse, cut the breast meat, weigh it, relate that data back to their siblings. In addition, once all this data is back, I do a breeding value sort, or EBV selection, based on an index. And then we do, again, at 24, 25 weeks of age, we do another body weight, check how they're walking, get all that data back, cull out anything that's ill, can't walk, etc., and then do this final EBV sort to pick our final candidates for breeding. Check them one more time before we transfer them to the lay barn. And at that point, we're just calling out anything that won't survive the full 32 weeks of lay, and then repeat that cycle with the next generation. I will pass it back to Xuechun for some cool technologies.
Okay, so I'll continue to talk about some innovations and automations that we have applied into our breeding program and also the selection program that Ryley just showed. So the first important technology is the RFID, radio frequency identification. So some of you may be already familiar with this word. So it has been commonly used in livestock industry to track animal activities and collect more day-to-day data. So next, I'm going to show you some examples about how we integrated that into our turkey breeding. So the first is the use of RFID with the feed station. So with the RFID, we're able to capture individual feed consumption information when animal enter into a feed station. So with this RFID and feed station, we're able to increase the number and accuracy of data we captured. So that includes how many times a bird visits the feed station and how much it consumed for each meal, and what time the bird go into the feed station and which station the bird visit day to day. So it gives us lots of data and lots of information there. So on the one hand, we're able to collect more accurate feed efficiency data. And on the other hand, it also helps us to potentially monitor the animal feeding behavior and their habitats from the feed station data. And overall, this will help us to improve our breeding program and improve our genetic gain on the feed efficiency. And the next example here is the animal weight system. So this system will bring us to a new era of selection on growth and also body weight. So together with the RFID technology, we're able to capture the individual bird weight when the animal step onto a scale. So before, how we, as Ryley showed just now, how we collect the body weight data is we do that at certain time point at certain age. So we collect that data manually with a crew stand on the scale and then lift the bird, and just to see the difference between those two numbers and calculate for the bird's body weight. So with this animal weighing system, so it also helps us to increase the number of data we collected on each bird. So instead of the body weight from a specific age, it's going to give us a growth curve. So it helps us to do that more accurately on the prediction and selection of growth and also body weight. It improved animal and also our crew worker welfare. So it just get rid of too much human and bird interaction and also handling job. So overall, it will help us to tweak the growth curve and also accelerate our genetic progress on growth and body weight improvement. And then the next example of using RFID is the automatic nest system. So this system, again, uses the RFID technology, and it captures the individual bird information when an animal enter into a nest. So this also helps us to automatically do the data collection on each bird on egg production. So additionally, currently for the nest system, we only apply that onto the breeder level instead of the GGP or GP level. So with this automatic nest system, we can actually apply that to the downstream level, and also to work on more G/E effects to see what's the fit difference or manage difference could cause onto the animals at different level. And overall with this, it also get rid of too much interaction and labor collecting eggs. So this automatic nest system will collect the eggs automatically, and also associate each egg back to the animal RFID. And so we got the egg production trace automatically from this system as well. And overall, this will help us to improve the accuracy on genomic selection of egg production traits. And then the second part of the innovation and cool technology is the CT scanning. So it also helps us to enhance the selection efforts and also accelerate genetic progress. And here the video shows an example of a scan for bird. So it really gives us lots of information and images here. So from organs into breast meat and also legs and bones, lots of information there. So the challenge for us is really to analyze all the information and extract all the information from the CT scanning. And so firstly, here is an example showing how we scan the birds. We have our Mr. Tom sit comfortable and confident here and waiting for his scan. And then this is the same, waiting for his scan. So the first piece of information we extracted and have been applied into our breeding program from CT scanning is the breast meat yield. So this video shows how the breast meat yield was detected from the CT scanning. So this really changed the word of how we select for breast meat yield. So before that was all the information were collected from the slaughterhouse. It was a cut up data. So we were not able to get any information from the selection candidates. So all the information are from the siblings and half-siblings or the relatives of our selection candidates. And we're not able to do too much. So the information is limited and not directly on the selection candidates. However, with the CT scanning, we're able to do in vivo measurements on selection candidates directly. And it only takes 6 minutes roughly for the scan of each bird, and it speeds up the data collection, and we're able to do 500 and now increase to 800 birds per week. So this increased the number of data we collected and also on selection candidates directly. So this will increase our prediction accuracy and genetic gain dramatically. And yes, we showed lots of things on the economic important traits: feed efficiency, egg production, body weight, and breast meat yield. What else? So this is one of the most famous research on turkey, and you probably see the similar picture on chickens from Dr. Martin Zudov's group. So this is on turkeys. And this research, they compared the random breed control line in 1966 versus a more than selected 2003 line. And at different age, there is a dramatic difference on the carcass yield. So it shows remarkable increase of breast meat yield between the heritage and the modern line. And the growth rate was doubled in between. And there are around 208 and 140 gram per year increase on body weight of toms and hens respectively. and also 20% better feed efficiency in modern line versus the heritage line. So at that moment in that study, they didn't find a significant increase of mortality in modern line. However, what scared us or concerned us is the difference between the cavity from the heritage line versus the modern line. So the breast meat increased so much, but the cavity decreased significantly. So does the bird have enough space for the organ to develop? And does the bird have like enough volume and size of the organs to support them for such dramatic and fast growth? And the same concern was actually found in broiler study as well. So the same trend, what they found is for body weight, it has increased roughly 4 times between the heritage and modern line. And then the breast meat yield doubled between the heritage and modern line. And feed efficiency improved almost double or 3 times between the heritage and modern line. However, the percentage of the heart and lungs decreased significantly in the modern line versus the heritage line. So that's one of the biggest concern, and it might be associated with increased mortality. And the hypothesis drawn from the broilers industry is that increased mortality and also loss of sudden deaths right before the slaughter age is an unintended consequence of genomic selection in broilers only focus on those economic important traits. So with the same concern in turkey industry as a bird has been selected for so long on those economic important traits, so we further look into our CT scans and try to find what else we can develop from there and what else we can select for in addition to economic important traits. So one of the important trait and interest we have is the lung volume or lung size. So working together with our digital phenotyping team, we were able to detect the lung size and lung volume from the CT scanning. So this video shows how the lung was detected from the CT scanning. There you go. Yeah. And then the next is the heart size and volume. So we can actually do, this is a sagittal wheel, but we can also do that on the axial wheel just to have a different way of detection and look at different angle. So this is what we're working on at the moment to do a better detection of lung and heart size and volume from the CT scanner, and also trying to figure out how we're going to put that into our breeding program. And meanwhile, we are in close collaboration with the university and Dr. Christian Bai's group, and we have students work on those data and those analysis as well to help us further integrate those traits into our breeding program. So what has been changed and what is being changing at the moment is instead of only focus on the production traits and economic important traits and probably a small amount of the others in from 1970s to 1980s, we're really switching to a more balanced breeding in the turkey industry. So from 2000s to today, the better production and quality of the products is still a part of our breeding program. But in addition to that, we're also improving our animal health and welfare. So the focus of animal breeding is not just on the gross breast meat yield. We also focus on the animal welfare and animal health and how do they respond to disease challenge and how are they robust to environmental changes and also more concerns on the animal welfare. And also we focus on the food security and reduction of environmental impact to improve the sustainability of the turkey breeding industry. And we're also trying to keep the genetic diversity and also the better use of resources. So overall, it's a balanced breeding program at the moment, and we're trying to make our turkey good on economic important traits and good at health and good at at production and good at everything. Just continue to improve our product performance for more balanced breeding. Last but not least, we would like to acknowledge our team. So this is a picture of all our geneticists from RTC and also each business units and also our breeding IT team. So this picture was taken by Ryley 3 weeks ago when we were in the Netherlands, Wageningen. We're having a global R&D event there. So it's really a great team. So we work together and help each other and share experience for a more balanced and a better breeding of multiple livestock species. So that's everything. And I think we have a little more time for questions and discussions. Yeah.
Thank you, Xuechun and Ryley. Do we have any questions from the audience? Colin?
Oh, perfect. Thank you for the great talk. This might be more of a question for you, Ryley, but it always kind of interested me with respect to turkeys and kind of almost the seasonality of them, because you have specific like Thanksgiving and Christmas and stuff like that.
Yeah.
So how do you maintain, like, because I'm assuming you want to maximize the output of all of these different farms and breeding stocks and stuff like that. So how do you balance having enough space to meet the need during those times versus keeping them full enough during the rest of the year, basically?
So turkey production, I would say the biggest section is actually further processed. So all of your deli meat. So size-wise, that's why from a turkey standpoint relative to a broiler, I know they're different species, different sizes to begin with, but how we can get away with such a big bird is because for the most part, they're cut up.
Mm-hmm.
It's not whole birds. You wouldn't be able to fit most of the birds that I deal with into your oven at home.
Yeah.
So that's that. In terms of like the seasonality spikes, I would say that's more planning side for commercial. So 20 or so weeks before Thanksgiving, they get a bunch of orders in, place those birds so that they are set up right at Thanksgiving for that market. Otherwise, it's just a continuous process for them of sending birds for further processed meat. You get your Disneyland turkey leg and all those kind of further cut up products.
Mm-hmm.
But yeah, from our standpoint, ours is a continuous cycle at the pedigree level, not super affected by seasonality of turkey consumption, I would say.
Perfect. Thank you.
No problem.
Hi, I would like to make a question about your last slide, the selection program.
Yep.
Is that selection program performed on which stage, which level of your chain? So isn't the great grandparents, the
Pedigree.
pure lines?
Pure lines.
Okay.
Yeah. There is a little bit of stuff. The grandparent and great grandparent sides, we do a little bit of egg production records, but that's really it. We don't calculate too much on them, but that is something that we want to look at in the future. Problem with turkeys is it's a complete turnover of generations. So from a data kind of power standpoint, we're already one generation out once we get that data back. So it's already about half of the power that it is to start. So it's a give and take of, do we kind of go after that data for use in our pedigree selection? Is it worth it at that point? It's a tough subject to talk about, but yeah, we do a little bit of data collection kind of downstream, but majority is on the pedigree birds themselves.
Thank you.
No problem.
I have a question for Xuechun. You said the feed efficiency, as well, like the timing when they go in. Is there a relationship of feed efficiency and when at the time of a day the birds actually eat?
We did not really look into that data for more like details. Like roughly for that's the use of the results for selection, we calculate the overall feed efficiency during certain age. For example, 4 weeks, 2 weeks at a certain age for each bird. Yeah, but we have lots of research work going on together with the students at Bahrain University and potentially Guelph University as well. So just to further look into that data. So the counter for us, it is good too with all those innovations and automation technologies. But another challenge we're facing is there are too much data. So too much information, and how we use that and how we further improve with all those information is what we're doing now.
We did look at, I think someone looked at the station that the bird went into and if there was any sort of like behavioral aspect to it. I don't think anything significant came out of it, but it is something that we might look at with the automatic weigh system as well, because the structure of that will line the middle of go right through the middle of the pen. So if they use the outer ones versus the center hole, for example, yeah.
Yeah, there we go. Okay, so first of all, you guys make the impression that you are a dynamic duo, and I want to congratulate you on the fantastic presentation that you've given. It's a pleasure to see new thoughts coming into breeding programs because I think it's probably time. So I think you're doing a fantastic job, and that's great. First question, with regards to the weighing, the automatic weighing equipment. Why in the center of the pen and why not at the feeding stations or somewhere else? Like for calves, we've got these half body weight scales. Why do it that way as opposed to integrating it into the feed stations?
We originally had the feed stations with scales. At the time, it didn't work out great. The data wasn't too good, whether it's the litter getting under them, the scales weren't super high quality. We've debated going back to that, but we might just implement this. So the video that was shown was the very first trial of kind of like a circle.
Yeah.
We've now had it so that it goes across the pen. And yeah, we can get into kind of more why we're picking that. We did one trial, got over 250,000 body weight records over 5 weeks on 500 birds. So it does work. And yeah, eventually we see a barn where there's feed stations lining the entire barn, automatic weigh systems integrated within it, somehow calculating feed and water consumption, body weights throughout the whole life. But to get there is a lot of capital, new barns,
So
internet.
Do you get all of, like with this system, do you think that you're going to get 100% of your bird weights, or is it like you're focusing your efforts on, I'm guessing, the will of the bird to perch? That's what the thing is based. Is that right?
A little bit, yeah.
A little bit. Like
there's some things that we're trying to force them, but
okay.
Yeah.
And there are differences between like different birds. So some of them with the pitch more often than the others. So there are different. So and after the next trial, we're going to change the design, the arrangement, and also the density of the birds to encourage them to step on the scale more often.
Okay.
Yeah.
Can I ask another question?
Yeah.
Okay. I've got like a million. So the next question is, when you were talking about walking school, and I don't know, I mean, yes, we've worked in turkeys before, but I mean, you guys are, you talked about walking score, and then Ryley, you made a comment about the commercial people who buy your birds, they're not going to be happy if their birds can't walk.
Yeah.
But at the same time, I'm thinking you're like way far up the food chain, right? And the birds that you actually sell in those bottom 2 layers of your pyramid, they're not the same birds. So how closely related, and are there any measurements on how closely related what you see in the commercial crosses are to what you're breeding?
Yeah, I think that's kind of the whole hot topic right now of expanding our insight into those lower levels. Because in the past, it's just been pedigree. So the CCPS birds, we're going to get livability, relate that back as a crossbred livability. If we can spare the people to get out to the farm and do walking scores on them, we will. Collect body weights on them, see the hybrid vigor there between the cross. But yeah, again, as I mentioned, it is difficult because it's 3 years. We always say it's 3 years from the changes I make today to the commercial product, just based on the number of steps in between. And it's also hard because it is that complete turnover of individuals. We don't have sires that are sticking around for 12 generations. So that makes it hard.
So with that, right, I totally get that. But if you were to make, so there's 3 years difference, right, between what you're doing and what you see in the field. And I get that that's really tough, right? But I guess the real question then is, are there genetics left over after 3 years? Are there any genetics left over after 3 years that you could still make some kind of an informed decision based on genomics or whatever at the nucleus level based on those?
Yeah, genomics will help with that kind of time gap. But it's also getting that data. Like commercial birds aren't individually banded and like that plays a huge role. So everything below pedigree pretty much is not going to be banded, and you won't know the individuals. So you'd have to go based on genotypes and like rebuild, which is a big process, but it's doable. But then you get back to that argument of the data that you're going to get back. Is that whole process actually worth that? However much that data is actually worth in terms of genetic gain. That's a big analysis that we'd have to get into.
I have more questions, but I'll wait.
More projects.
Anybody else have questions?
Yeah. Is it flashing green?
No.
Is it green?
Is it green?
Right.
No.
Here, take this.
No, I have one.
Okay, good.
Is it good? Okay.
It's good.
My question is, do you take into account that the animals about the scale, the animals that do actually walk on it have already better walkability compared to other animals?
That's another correlation aspect that we'll have to analyze.
Yeah, because if the bird's in pain,
Yeah.
won't walk on the scale.
Yep.
Yeah, okay. Also, one more question.
Yep.
And since history, after hybrid joined Hendrix, what and how things changed?
Ooh, that's a good question beyond our time. Yeah. I was not around then, so I couldn't say, but
You want real answers, stop the recording.
But I assume because Hendrick Genetics is a multi-species company, so instead of doing solo only on turkey, so you gain lots of experience and knowledge share from the other species as well, and you got a more stronger team to work together.
Mhm.
And there's a question online.
Ooh.
One last question.
Oh, okay, go ahead.
The Pure Lines, how is close to management and housing compared to commercial ones?
Close as we can get it.
Okay. You make sure that you're close to commercial and not the other way around, right?
Yes.
Okay.
Yeah. So go ahead.
But the big difference is biosecurity level.
Yeah.
We can't do that at the same as the commercial level.
Yeah. In terms of like litter quality, feeding program, lighting, densities, we try and match. What I say when I go to the farm is you want to be average. So you think of a pet turkey and then borderline animal cruelty. We want to be right dead center so that our environment matches the majority of commercials. That's what we say to farms.
Online.
Okay. Jacob is asking when selecting for desirable traits using purebred lines kept in optimal health conditions, what implication does this have when applying those same selections to commercial breeding programs operating under less stringent health standards? Specifically, how will genetic and environmental factors, G by E, influence the outcome?
Yeah, so I think we just touched on that, but basically we're trying to match our environment the best we can to commercial so that we have minimal G by E. There was a point, I think it was around the 80s, where hybrid kind of got into this point where we were treating our birds really, really well and selecting on that environment. And then when you threw those birds into a worse environment, they did really bad. So we kind of have to treat our environment. It is hard too, because you go to a farm from kind of just a human aspect. You walk into a barn, you want these animals to be treated well, but we come in and go, okay, I don't want you to be too good. So it is difficult, but we do the best we can, and obviously incorporating the biosecurity so that our birds don't get sick. In terms of like litter and everything, best we can to match that commercial, so the G by E effect is as minimal as possible. This would be the answer.
But as also like shown in the previous slides, we have the CCPS, which is combined crossbred and purebred selection. So, well, it has been well known that crossbred trait is not necessary to be the same as the purebred trait. So there are some genetic correlations in between, but not the same trait. So we're developing the CCPS system. And we challenge the crossbred bird and we mimic everything that's going to happen at the commercial level and we collect that data. So it's just a better data collection versus a commercial farm. And we have the industry record here and we'll put that into our breeding program and hopefully that will help us to go to the right direction for like with commercial farming producers. Okay, go ahead.
Okay. I just have a quick question about like the CT scanners. I know you guys are currently like looking at heart and how to measure that. Do you intend to look at the liver and what are your plans for that if you do, since they're like physiologically speaking, like right next to each other?
Hey, if you can distinguish it, hired.
Okay, noted.
Yeah, we'll look at organs the best we can. As I've mentioned in a couple of times when I get in this talking classes and whatnot, biologically you're looking at something that's the same density. So if they're right next to each other, which they are in the organ cavity, you can't really distinguish between the organs. So if we brought up that scan again, the organs sitting at the bottom is just kind of one gray blob and then it stops. That's why the lungs were relatively easy, because they're kind of separated at the top. But yeah, other organs, it's going to be difficult, but it's on our list to look at.
Still about the heart and lungs, I was wondering if you said that it's possible that the size of them are related to mortality. Was seeing this correlation is proved, or is still something that it may be?
Investigating.
Yeah.
Okay.
Yeah.
Okay. And then if there is a correlation, how much do you think this is going to reduce mortality that much?
So it depends because there are so many reasons for mortality. So it could be a leg issue, it could be like heart and lungs and the others. So it's just hard to tell. Yeah, but if that's caused by the heart and lungs for the majority of the mortality, so it should improve significantly on livability.
It'll also be difficult to select for though, because we don't want to go. My assumption is you're going to have negative correlations with economic traits.
Absolutely.
So it's that balancing act of progress, but still continuing to make a better turkey for commercials.
Thank you.
Okay.
Where do you put the air pipe in the
Research. Where?
I can just repeat it. The location of the RFID tag, we had a picture of it. It wasn't in this presentation, but it's the wing band. So the wing band's like about this big, and it just clips onto the skin on the wing.
Back to the environmental, way back. I had a follow-up question. You said you want to imitate the commercial part, right? But now these turkeys are still growing when they're at your level, right? So in dairy, it is if you have a calf and you feed that ad libitum for the first 6 months, the metabolism is so increased to other calves that it will be on the other one hand a high performing cow, but also hooves get longer, quicker, and everything. Do you have to take that into account with turkeys as well and restrict them there to have a?
They're fed ad libitum everywhere basically. So that aspect in particular is the same. Yeah, you won't really have cases where they're selectively fed. Might get there in the future, I don't know. But for the most part, they're fed ad libitum. So it's more of, from a turkey standpoint, in terms of environment, the biggest thing is the density, and then the litter. And then you can also go into like feed quality and water quality. But if you're a good grower, that stuff should be kind of taken care of. But it's more the density. You give a bird 4 square feet, it'll do better than a bird with 2 square feet. So finding that good range of typical densities is what we're doing with our program. And then, yeah, making sure that the litter is not too good. A little bit wet, not too dry. Yeah.
Last question, sorry. Guys, you guys have both joined industry relatively recently.
Yes.
I think. What was the most surprising thing coming out of academia and going to an industry partner? Just for all these people who are on the cusp of doing something, like what was just, where were you like, when you look back, what were you like, oh, that's different than what I thought it would be?
I don't think that, well, you know me, I didn't like the writing aspect. So I don't really have to write a whole lot, which is nice.
Emily doesn't do that at all.
That's why I've had dynamic duos my whole journey. Emily and I with writing, Xuechun and I now, it's great. I don't know, I from an industry standpoint, I don't know if it's different with different companies, but hybrid is very open. You have lots of connections, which is really nice. Obviously, I still have the flexibility to come here and talk with everybody that I worked with in the past and collaborate there. Yeah, I think day to day, though, I really enjoy my job. I get a little bit of travel here and there. Come give presentations. I could just sit at my desk at home. I could go to the office and sit at my desk. If I'm tired of desk work, I can just call up the guys at the farm and say, I'm coming, what do you need help with? And go a little hands-on aspect. So there's lots of flexibility, which is good to have, and I find is good. So.
To me, I felt the biggest difference is when I was a student, when I was doing research, I don't think too much about applications. So I just find a tray, and it doesn't matter how difficult we would be able to measure it. We'll do it, make it possible when we are doing research. And I actually have the ability to give the kinetic correlation at probably around DUA. and draw conclusions here down, finish my business. But when I go into the industry, we seldom run keywords. We still do that sometimes, but workflow probably doesn't make too much sense. And we're not able to find too much information from the keywords either. But always I got the question is how we apply that into the farm and how easy we could do that and shape that model. So that's the biggest difference application.
I got that experience from Ben already. So.
Yeah. We try, right? We really try to get you guys into the real world.
Yeah, I really enjoy it.
Fantastic. Fantastic.
Thank you for having us.
Thank you.
Yeah, thank you guys. Thank you, Xuechun and Ryley. Very nice presentation. Very nice discussion. And yeah, this is the last CGIL seminar of the semester, the last CGIL seminar for Samla and I. So yeah, thanks everyone who joined us in person and online, and we'll see you next semester.
No, not a week.